Hello everyone. Myself V. Krishna Veni, working as assistant professor in physics department from Marri Laxman Reddy Institute of Technology and Management. So today I am going to tell about the one topic, that is de Broglie hypothesis and matter waves, which is there in the quantum physics and solids. So last class, module 1, I discussed about the black body radiation, introduction to quantum mechanics, black body radiation and photoelectric effect and its applications. So this is the second module. In this, I am going to explain about the de Broglie hypothesis and matter waves. So de Broglie was discovered that in 1923, de Broglie was discovered that matter has the dual nature. So dual nature means that is the wave nature as well as particle nature. So in 1923, de Broglie was discovered that the matter has dual nature. For this, he was awarded the Nobel Prize. That is by theoretically. So it was verified that discovered that the matter has the dual nature, and later it is experimentally verified by Davison and German. So here de Broglie was discovered the matter. Matter means a solid, liquid and gas which has the dual nature by theoretically, and later it was experimentally verified by Davison and German. So now how he proved that matter has the dual nature, that is by taking the electromagnetic radiation. So electromagnetic radiation is simply the light wave. So the light wave, which is electromagnetic radiation, which has taken by the de Broglie to prove the matter has the dual nature. So electromagnetic radiation has the dual nature, that is wave aspect as well as particle aspect. So radiation is having the dual nature, that is wave as well as particle. So how it will be wave act like a wave, how it will be act like a particle. So from the Max Planck quantum theory, the radiation has the wave aspect, that is E, the energy of radiation E is equal to h into nu. That is from the Max Planck quantum theory, the energy of radiation is given by E is equal to h into nu, where h is the Planck's constant and nu is the frequency of radiation, and where nu is replaced by C by lambda. So why it is replaced by C by lambda? That is frequency nu is equal to C into C is equal to nu into lambda, and nu is equal to C by lambda. So here the velocity of light is C, which is the product of frequency and wavelength. So here frequency is equal to C by lambda, that is replaced nu in place of nu, it is replaced by hc by lambda. So this equation E equal to h nu is equal to hc by lambda from the Max Planck quantum theory. So this is known as wave aspect. Why it is known as wave aspect? Because here the term which is described the wave is nu, that frequency, the term which describes the wave is nu. So that's why frequency is the term which describes the wave. That's why it is known as wave aspect. So that is from the Max Planck quantum theory, E is equal to h nu, that is equal to hc by lambda. This is the first one taken by the de Broglie, that is radiation, electromagnetic radiation has a dual nature. So from this wave aspect is from the Max Planck quantum theory, E is equal to h nu and nu is equal to C by lambda. From this the equation will becomes to hc by lambda. And next to where h is the Planck's constant and c is the velocity of light, lambda is the wavelength of electromagnetic radiation, and nu is the frequency of electromagnetic radiation. So next one, after Max Planck, again de Broglie was taken the Einstein mass energy relation. Einstein's mass energy relation is what? The energy is in the form of mass, that is E is equal to mc square. So E is equal to mc square from Einstein mass energy relation. So this is known as a particle aspect. Why it is known as particle aspect? Since m is the mass of the particle. So mass of the particle means it is a particle aspect, whereas in E equal to h nu, that is a wave aspect, where E equal to mc square, that is particle aspect. So where m is the mass of the particle and c is the velocity of light. So here E equal to h nu, hc by lambda, and as well as E equal to mc square. Both are the energies of electromagnetic radiation. So both the equations are equal to each other. When it is equal to each other, what will happen? That is h nu equal to mc square. H nu is equal to mc square, and then by substituting nu equal to c by lambda, that is hc by lambda equal to mc square. Later, by simplifying the equation, by taking the value of lambda, that is wavelength, is equal to h by mc, where h is a Planck's constant, m is the mass of the particle, and c is the velocity of light. So here, in place of c, substitute v. What is v? Velocity of material particle. By substituting velocity of material particle v in place of c, then what the equation will becomes? That is lambda equal to h by mv. So h by mv means what? That is mass into velocity. That is a product of mass into velocity. What that is will becomes to momentum. That is lambda equal to h by p. So p is what? Momentum of the particle, momentum of the material particle. So the material particle is, in the last class only I said, that is electron, proton, and a neutron. So here P is equal to m into V, where m is the mass of the material particle. That is material particle may be electron, proton, and neutron, and V is, that is velocity of the material particle. So here hence what he can conclude, de Broglie was concluded that by taking the universe, entire universe is consisting of energy and radiation. Both entire universe is fully consisting of, one is in the form of energy, another one is in the form of matter. So energy is known as radiation. In another name for the energy is radiation, that is electromagnetic radiation, and matter. Matter means again solid, liquid, and gas. So total universe, entire universe is consisting of energy as well as matter. So if the radiation has the dual nature, so matter is also having the dual nature. Why? Because so total nature likes the symmetry. Symmetry means one likes dual nature, another is also likes the dual nature. That is, if radiation has the dual nature, so obviously the matter has also dual nature, because entire universe is consisting of energy and matter. So if one should have the dual nature, another is also should have the dual nature. That is, radiation has dual nature, so matter has the dual nature. So what is the de Broglie hypothesis? Hypothesis is here, it is dual nature of the matter. So dual nature of the matter was proved by theoretically by taking the radiation. The radiation has the dual nature, so obviously matter is also having the dual nature. So next here we are going to determine the energy, that is expression for the electron de Broglie wavelength. So that is de Broglie wavelength. Why electron de Broglie wavelength? We are going to determine by using the some assumptions. So what are the assumptions here taken? That is, if the electron, here it is, we are going to determine the wavelength of electron. So that's why we are going to take the electron. So yeah, when it is the electron will get accelerated by applying external potential. So when the potential is applied to the material, the electron is get accelerated. So when the electron is get accelerated, what will happen? It have the kinetic energy. The kinetic energy is what? Half mv square. Half mv square in place of m is mass of the material particle. V is what? Velocity of the material particle. This kinetic energy is replaced, the is equal to product of charge of the electron and also potential applied, that is E into V. So when we square the mass, both the side multiply with m LHS as well as RHS, and take the 2 in the denominator going to RHS, then what will happen? M square V square is equal to 2MEV. So here m square MV is what? What is MV? The MV is momentum. That is, MV is momentum, that is represented by P. So P is equal to m square V square is known as P square. P square is equal to 2MEV. So P is equal to under root 2MEV. So EV means here simply written as capital E. So capital E is equal to E into V. So P is equal to under root of 2MEV. So from the de Broglie wavelength in terms of energy, what is in terms of energy? That is a de Broglie wavelength, that is lambda equal to h by under root 2me. So this is what expression for the wavelength of the electron. So here, so when we substitute in place of E, small e into small capital V, what is E? Charge of the, in this substitute in place of E is equal to small e into capital V. So where E is the charge of the electron, V is the potential applied, and m is the mass of the electron, h is the Planck's constant. By substituting all the values in the equation, what are the equation? That is h equal h by under root 2mev, where h is what? Planck's constant. M is what? Mass of the electron. E is charge of the electron. V is the potential is applied. Everything is the constant but except voltage is applied. So voltage is a variable. So by application of voltage only the electron get accelerated. So by substituting all these values, you will get the equation called as lambda equal to 12.26 by root V angstrom. So here angstrom is the unit of the wavelength. So here de Broglie hypothesis, here it is matter has the dual nature. So for this we have derived the wavelength of the material particle. So here the wavelength of material particle having the many forms. One is lambda equal to h by p, and another form of the wavelength is lambda equal to h by under root 2me, and third form is lambda is equal to 12.26 by root V angstrom. So it's about your de Broglie hypothesis and expression for electron wavelength. And next one, matter waves and its properties. So matter means a material particle. So the material particle is moving, then the matter waves are produced. That is here a wave which is associated with a material particle is known as matter wave, or the wave which is exhibited by the material particle is known as matter wave. So here the characteristics of the matter wave are properties of the matter wave. So how you can give the properties of the matter wave? By using the formula. What is the formula? Lambda equal to h by p or lambda equal to h by mp. So here from de Broglie hypothesis, de Broglie was discovered the matter wave. So that's why we are using the matter wave wavelength, that is lambda equal to h by mv, that is h by p. So h is again the Planck's constant, p is the momentum, and lambda is the wavelength. Where p is momentum, that is equal to product of m into mass of the material particle and velocity of the material particle. So by using this formula, we can define the properties, or we can initiate the properties of the matter waves. What is the first property? When the particle is lighter, the wavelength will be heavier. So otherwise, when the particle is heavier, the wavelength will be lighter. So from the properties can be defined by using this formula. That is, the first property is the lighter the particle, heavier the wavelength. Next one, the faster, that is the velocity is faster, velocity is more, wavelength is less. That is, by using the formula we can define, we can use the two properties. What are the two properties? When lighter the particle, heavier the wavelength, faster the velocity of particle, and the smaller will be the wavelength of the material particle. And third property is the matter wave having the wavelength of matter wave will be independent of charge. It does not depends on the charge. It may be an electron, that is a negative charge. It may be a proton, it is a positive charge. Neutron is a neutral particle. There is no charge upon the neutron. So there is no dependence of the charge of the material particle. It is independent of the charge. De Broglie wavelength is independent of charge or nature of the particle. So it does not depends on the charge. It's independent of the charge as well as nature of the particle. And next one, the matter wave is not a electromagnetic. It is a matter wave is not at all a electromagnetic wave, but it is a new kind of waves. So next one is the material particle having the dual nature. So that is, here no single phenomenon cannot exhibit the both natures at a time. That is, it does not exhibit the particle nature, and also wave nature at a time. One time it is a particle nature, another time it is a wave nature. Simultaneously cannot exhibit the particle and wave. That is, no single phenomenon exhibit the particle and wave nature simultaneously. So these are the properties of the matter wave. That is based on the formula. There are two properties, and next one it is charge independent, and next one is a new kind of waves, and the fifth property is no single phenomenon cannot exhibit the particle and wave simultaneously. Next one here, the velocity of matter waves is greater than the velocity of light. So velocity of matter waves can be exceeded, velocity of matter waves can be greater than or faster than the light wave, can be proved by the formula, that is again the Max Planck quantum theory as well as Einstein mass energy relation. So here what is the next property of matter wave, that is the matter waves can move faster than that of the velocity of light. So how it will be, there is a mathematical derivation, that is E equal to h nu, E equal to mc square. This is E equal to h nu is the Max Planck quantum theory, and E equal to mc square, that is mass energy relation. So mass energy relation. So these two are the energies are both same electromagnetic radiation energies. So by this we are going to determine nu is equal to mc square by h. So the wave velocity, the matter wave, a group of, if the electron is moving around the nucleus, the electron which is moving around the nucleus, which will form a wave, the wave is having the velocity, that is known as matter wave velocity. Matter wave velocity is represented by omega, which is a product of frequency and wavelength. So frequency and wavelength nu into lambda, where nu is what, mc square by h, and lambda equal to h by mv. So by simplifying or by cancelling h and as well as c square by v. So when the omega will be very greater than c, when v will be less. So when v will be less, omega will be very greater than c. So as the particle velocity cannot exceed the velocity of light, then omega is greater than the, or matter wave velocity is greater than the velocity of light. So here v is in the denominator. So if the v is less comparatively c, then obviously omega will be very greater than c. So that's why matter wave velocity is very greater than the velocity of light. So it's about the matter waves and its properties. The matter waves and its properties is based on again de Broglie hypothesis and its wavelength. The next one is wave particle duality. So here duality means again wave and particle. So what is the nature of waves and what is the nature of particles? So that is wave particle duality. First one is a wave. So what is the nature of wave? So a wave is spread out throughout the region or throughout the space. It cannot be fitted at one place. It cannot be fitted in a particular location. It will move here and there. So that is a wave which can spread throughout the region or particular space. It cannot be located at here and there. It will move from one place to another place. That is known as wave. So a wave which is nothing but a disturbance created in the media. So that is actually wave is nothing but a disturbance that is spread out of the disturbance. So here the terms which can be described the wave, what are the terms describe the wave? That is frequency, wavelength, phase, amplitude, intensity. So here frequency, so the frequency here, suppose this is a wave, here the number of cycles per second is the frequency. Wavelength, the distance between two crests or two troughs, or distance between this one and this one is known as wavelength. And next one is the distance between these two are the wavelength. And next one is phase, the angle between these two are the phase of the wave. And amplitude, how much the distance the particle is vibrate long, the large displacement is known as amplitude. Intensity, it is the brightness of the wave, that is intensity is more or less. So these are the terms which can describe the wave, that is frequency, wavelength, phase, amplitude and intensity. Next one is the radiation. The radiation is behave like a wave. The experiments called interference and as well as diffraction. Not only interference and diffraction but also reflection, refraction. So So these are the properties of the wave which can describe, that is the particle wave cannot be located at particular position. It can move from one place to another place. A disturbance created in a media is a wave. The terms which can describe the wave known as frequency, amplitude, intensity, wavelength, etc. So the experiments called as interference, diffraction, reflection, refraction. These are the experiments called as experiments, light properties. This can be behaves like a experiments known as wave behavior. Next one is nature of particle. Particle can be located in a particular position is known as particle. So particle can be located in a particular position. It can have mass m, velocity v, momentum p, and energy E. So here, what are the experiments proved the particle behavior of the radiation? That is what? Particle, that is photoelectric effect, Compton effect. Photoelectric effect, Compton effect gives the evidence of the particle behavior. Next one, interference diffraction will describe the wave behavior, whereas black body radiation, photoelectric effect describe the particle behavior. Wave and particle duality. First, nature of waves. Actually, what is the meaning of wave? The wave is disturbance created in a media. So here the wave cannot be specified in a particular location. It can move from one place to another place is a wave. So here the radiation has the wave behavior from the experiments called interference, diffraction, reflection, and refraction. The next one is the terms which can describe the wave behavior known as frequency, wavelength, amplitude, intensity. So here wavelength is the distance between two crest as well as two trough. So frequency is known as the number of cycles per second. Amplitude is the large distance the particle vibrate, that is known as amplitude. So these are the terms which can describe the wave. So the experiments known as interference diffraction will describe the wave behavior. So it's about the nature of the waves. Nature of particle. So what you can say, particle means it can be located in a particular position, then it is known as a particle. Particle cannot move here and there. It will be located in a particular position. So it have the position as well as momentum, mass, velocity. So these are the terms which can describe the particle behavior. And next one, the experiments known as photoelectric effect, black body radiation, Compton effect will describe the particle behavior. So from this one time it is a particle nature, another time it is a wave, but not both simultaneously. This is what properties of the matter waves means. One time it is behave like a particle, another time it behave like a wave, but not both simultaneously. So next class we will discuss about the Heisenberg uncertainty principle. That is, one time we can find position, another time we can find momentum, but not both simultaneously. That is, there is uncertainty in finding the position, uncertainty in finding the momentum. That will be discussed in the last class. So up to this we have completed introduction to quantum physics and solids, black body radiation, photoelectric effect, de Broglie hypothesis. Next one, matter waves and its properties, wave particle duality, that is nature of waves and particles. So next class we will discuss about the Heisenberg uncertainty principle. So I have referred from the Applied Physics by P.K. Palaniswamy, that is matter waves and its properties, as well as de Broglie hypothesis. Thank you.